everyone, my name is Mahtab and today I'll be presenting the impact of gamification on high school math performance. In this presentation, we are going to explore if turning learning into a game actually helps students perform better in difficult subjects. We can begin by looking at the context of this study. This research took place at a STEM-focused institution in Queens, New York. You'd expect a school focused on science, technology, engineering, and math to excel in all of those categories. However, take a look at the graph on the screen. While students are performing well in history, look at the bars inside of the red box. These are the 2024 region scores for geometry and algebra 2. They are sitting at 66% and 64% respectively. Despite the school's STEM focus, these math scores are lagging behind. This discrepancy raises a critical question. Are the current traditional teaching methods failing these students? And if so, can a different approach, specifically one involving technology, fix it? This brings us to the concept of gamification. To ensure we are all on the same page, gamification is defined as the approach of incorporating game design elements such as points, leaderboards, and competition into non-game contexts such as educational settings. The goal is to take the engaging aspects of video games and apply them to the classroom to boost participation and motivation. But does this actually translate to better test scores? To find out, I first turned to existing literature. There is a strong body of research supporting gamification. For instance, researchers Tariq et al. And Pintrinch have argued that effective teaching must target student engagement. Their work suggests that engagement is the key driver that develops critical thinking skills and boosts academic performance. The logic is simple. If students are interested in having fun, they will apply their knowledge more effectively. Therefore, gamification should theoretically improve grades by making the material more engaging. However, the literature isn't entirely unanimous regarding the types of motivation. A study by Khalid et al. Focused on medical school students. They found that while learning engagement did correlate with a high GPA, the specific type of motivation, whether intrinsic, doing it yourself, or extrinsic, doing it for a reward, didn't necessarily impact the GPA itself. Crucially, however, this study and many others like it were conducted in higher education settings, like medical schools. There is a distinct lack of data on how this applies to high schoolers whose maturity levels and response to competition might be very different. Finally, I looked at the work of Van Eck, a video game developer and researcher. He emphasizes that for learning games to be effective, they must be problem-based and placed in real-world contexts. He argues that applying knowledge allows students to internalize concepts. Like the other researchers, he stresses engagement, but this leaves us with the question, does a competitive, rapid-fire game like Kahoot provide the problem-based depth Van Eck is talking about, or is it just a distraction? To synthesize the literature, we know that engagement and motivation correlate with high performance. We know gamification targets this engagement. But here are the gaps. Previous studies rarely focus on STEM-specific high schools, and they rarely look at specific difficult math courses like geometry and algebra 2. Most studies are broad or focused on university students. My study aims to fill this specific gap. This leads directly to my primary research question: to what extent does competitive gamification affect the performance of high school students in geometry and algebra 2 at high school X? Based on the literature favoring engagement, I formed the following hypothesis. Gamified intervention will have a positive impact on student performance as compared to traditional methods. Essentially, I predicted that the students playing the game would score higher than those taking a standard paper quiz. To test this, I used a mixed method experimental design. This means I utilized quantitative analysis, looking at the raw numerical scores from tests, and qualitative analysis, looking at survey responses to understand how the student felt about the methods. Using both allows us to see just how they performed, but why they performed that way. Here's how the experiment was structured. I worked with 4 classes, 2 geometry and 2 algebra 2. In phase 1, all classes took a traditional paper baseline assessment to establish their starting level. Then there was a 1-week gap. This week was crucial to eliminate short-term memory retention of the specific questions. In phase 2, the classes were split. The control group took another paper assessment. The experimental groups, however, used Kahoot, a competitive game-based design platform, to answer the same questions. This allowed me to directly compare the performance of paper versus paper against paper versus Kahoot. To analyze the numeric data, I used 2 specific statistical tools. First, I used the Mann-Whitney U test. Because my data was not normally distributed, it was an ordinal, this test helped me determine if the difference in scores between the groups was statistically significant or just due to chance. Second, I used the rank by serial correlation. This measures effect size. In simpler terms, The Manwit tells us if there is a difference, and this correlation tells us how big that difference actually is. For the qualitative side, immediately following phase 2, students in both the control and experimental groups were given a Google Form survey. I analyzed the written responses using a 4-step thematic analysis. 1. I created codes for recurring words or sentiments. 2. I grouped those responses. 3. I identified common ideas such as stress or fun. And 4. I created a narrative to explain the student perception. Now let's look at the results, starting with the geometry classes. If you look at phase 1, the baseline, the means were fairly similar, 4.42 and 4.1. But look at phase 2 in the red circle. The experimental group, the ones playing the game, saw their average score drop to 3.31, while the control group stayed steady at 4.30. The Manwit and U p-value was less than 0.001, meaning this result was statistically significant. The rank by serial correlation showed a large negative effect. This was the first sign that my hypothesis might be wrong. We saw a similar trend in the Algebra 2 classes. In phase 1, the groups were almost identical, 3.88 versus 3.83. In phase 2, the control group maintained their 3.88 average. However, the experimental group playing Kahoot dropped to a 3. Again, the statistics confirmed a medium-large negative effect. Across both subjects, the students playing the game performed significantly worse than those taking the paper quiz. So the scores were down. But what did the students say? This is where the qualitative results get interesting. In the Kahoot survey, the most common themes were increased engagement, 23 responses, and fun/enjoyment, 22 responses. Students felt like they were learning. They reported being more motivated. However, notice the second row. 16 students specifically mentioned causing stress and pressure. This gives us a clue as to why the scores might have dropped. Comparatively, the paper quiz survey was much more standard. Students mentioned clarity of concepts and positive experiences, but there were 0 reports of time pressure or stress causing them to fail. 14 students noted negative experiences, mostly related to finding the paper format being boring or frustrating, but not high pressure. Bringing this all together for the discussion, first and foremost, the quantitative results proved my hypothesis incorrect. I predicted gamification would improve performance. Instead, both experimental groups had significantly worse scores with a large negative effect size. The competitive gamification actively hindered their ability to demonstrate their knowledge. Secondly, we uncovered a fascinating contradiction. 64 survey responses indicated that students felt more engaged and motivated by the Kahoot. This aligns with Pinterest's theory that students want to learn when engaged, but this perception of learning did not match the reality of their performance. The responses indicating pressure suggest that the competitive element, the timer, the leaderboard, the music, created a high-stress environment that blocked their cognitive ability to solve math problems. Why are these results significant? For point 1, it highlights the danger of relying solely on student perception. Students might say that they love a teaching method, but that doesn't mean it's helping them learn the material. For point 2, it shows that different subjects require different approaches. Rapid-fire gamification might work for vocabulary words, but for complex math requiring multi-step problem solving, the time constraints of a game like Kahoot can be detrimental. In conclusion, this study suggests that Kahoot may be an ineffective tool for increasing performance in high school math, despite being an excellent tool for increasing interest. Students favor the game, but the factors of time constraints and competitive stress are likely the main perpetrators of the decreased performance we observed. Research is never without its limitations, so I want to address 2 in my study. First, it was short-term. The intervention only lasted a week. It is possible that over a semester, students would get used to the pressure and improve. Second, due to class time constraints, the quizzes were pretty short, only 5 questions. A longer, more comprehensive assessment might yield different results. For future research, I recommend 2 adjustments. First, utilize longer quizzes to get more reliable data points. Second, conduct interventions that last longer than a week. We need to see if the novelty of the game wears off or if the stress decreases over time as students adapt. Finally, what does this mean for teachers right now? Educators need to align their teaching styles with their specific classes. Math teachers specifically should be wary of using high-pressure gamification for complex topics. Teaching interventions must not only target academic abilities but also consider cognitive factors like stress tolerance. Just because a tool is modern doesn't mean it fits every subject. Here are the references that I used to support my literature review. Thank you for your time and attention in listening to my presentation.